guys, good morning. Welcome to the flight dynamics class. Today we are going to discuss about the aircraft or airplane pull-up maneuvering. So let us say consider the airplane is flying in a level flight. That time lift will be into weight. This is a level flight condition. Let us say this is a level flight aircraft where the lift is equal to weight and thrust equal to drag. So now the pilot is changing the pitching angle, that is the angle of attack, the pitching angle. It will start pull up, it will start elevating to the pull up maneuver. So that time lift is increasing with respect to W. So this time it will start producing a curved path. Let us take a point, it will start pitching. So this aircraft starting with respect to the radius R, it will start at lift and this will be a weight. So it will start some velocity, it's a curved path. That will help to understand how the pull-up is maneuvering. So this time the force equation will be, this force equation will be mass of the aircraft and the velocity, flight velocity, that is a V infinity square over pi. This is called turn radius. This is the R is a turn radius. And this rate will be turn rate omega equal to d theta by dr. Now we are going to find out what is the turn radius and the turn rate from the picture pull-up maneuvering. That time the equation will be m mass of the aircraft plus d, the radius of the aircraft, is equal to lift times. This will be resolved into two cases, that is the vertical and the horizontal component, that will be equal to W cos theta. So this is L minus W cos theta. So here the theta of this pull-up maneuver is very small. So cos theta will be taken into 1. So mass time V infinity squared by R is equal to L minus W. Now we need to find out this turn radius as R, and let's take turn radius is equal to R, it is small r. So, and M equal to weight times into weight by gravity. So substituting all this parameter here, we are getting W by G V infinity squared by R is equal to L by W. From this we can get the turn radius of aircraft during pull-up maneuvering. So we will get R equal to W V infinity square divided by G L minus W. Right? So rearranging this equation, W V infinity square G, we can write it as L by W is equal to 1. We can take the W out, that is the weight of the aircraft, where this L by W is here, that is a load factor. This is a load factor. Now we can replace the L by W as a load factor in this equation, and we can eliminate this weight by weight. So turn radius R equal to V infinity square divided by G. This is a load factor minus 1. So this is the turn radius of airplane or aircraft during the pull-up maneuver, pull-up condition. turn rate omega equal to d theta by dv. Right? So omega equal to right. Now the turn rate equation will be v infinity by r, where from this we can get the v infinity value is equal to v infinity is equal to this is v infinity. That will be v infinity by r. So we have the r value directly we can substitute, that is v infinity square divided by g load factor minus 1. So we can cancel this v infinity. This is g by g n minus 1 divided by v infinity. This is the turn rate omega of the aircraft during pull-up condition. Right? So we have find out the for pull-up maneuvering condition. We have got the turn radius equal to v infinity square by g into load factor minus 1. For turn rate omega, this is omega is equal to g into load factor minus 1 by v infinity. So we will see in the next class. Thank you. We will discuss in the last class. Thank you.